We are today going to take a look kind of at our part 2 of section 5.1 here with the graphing of quadratics. I wanted to take a little time here at the start, and we're on the second page of the packet, to review a few things from yesterday, but also start to introduce some more things that we might be able to take from one of these graphs. So, this time, we're given a couple of graphs, and we are supposed to be figuring out some of the values from it. So let's see. My vertex. Now again, my vertex is that point where if I were to take that point and put a line through there, I'd cut my graph in half. It'd be symmetric. But it also gives me the idea of, do I have a max or a min going on with something? So again, from yesterday, when we're opening upward, we're going to have minimums because that value is at the bottom of my graph. So my vertex, let's see here, -2, -3 would be that vertex. Now, one of the things we didn't talk a whole bunch about yesterday is this thing called the Axis of Symmetry. And it's a real fancy name for a pretty simple concept, actually. What the Axis of Symmetry says is if we can find a place where I could draw a line and it would evenly bisect or create two congruent halves of my parabola, that's what it would be. But we need to have an equation for that. So there's two kind of obvious things with this. One, since I have a vertical line going through here, it's going to be an x equals equation. And the second kind of hint that we get is it's always going to go through my vertex. So if I just use the x value from my vertex, I'll have the axis of symmetry each time. So my axis of symmetry here would be -2. The other thing I can even get from all of this, you're like, isn't it enough already? We got the vertex, we got the axis, we figured it's up, we know it's a minimum. Wait a minute, how am I going to come up with the equation for this? Well, when we think back a little bit to our standard form before, and this is something that comes up quite a bit with these, when I know what my vertex is, my vertex gives me my h and my k values. You're like, okay, but I don't know what a is. I don't know what that value is in front. Typically on the ones that I give you like this, there's not going to be a stretch or a shrink to them. They're just going to be pretty atypical. So for the ones up here, my a value is just going to be 1. I'm not going to expect you to be able to look at a graph and figure out those things off the top of your head yet. Okay. So for the ones we're doing, it's almost as if we're not even going to worry about that a, because if you put 1 in front of a set of parentheses in front of a quantity, it really doesn't mean anything. So all I'm going to do, x minus, so the opposite of h, so the opposite of -2 would be +2, and then I just keep my k value. What this is basically telling me is, if I'd have started this parabola back at the origin, think about when we were doing shifts before what these meant. This would have been left 2 and down 3. If I'd have started this parabola at 0, 0 and gone left 2, down 3, there's my starting point again. There's my vertex. So those kind of interconnect with some of the things we've done before. All right, so this next one. Okay, I'm going to do something strange. Now, people watching later won't be able to know this, but you're going to. On number 8, I want you to try to fill in the blanks and see if you can come up with those 4 things on the right and the equation. And then we'll come back together here and see if we have answers that match up here. One slight twist on this one. I'm going to see if you pick up on it. here. The one thing I'd be curious to see if some of you didn't think about, when you get down to the equation, remember, if it's opening up, my a value is going to be positive because that's one of the ways I know that it opens up or down. Since this one's opening down, that value, and I can put -1 or I can just put the negative out front, but that's going to tell me, hey, this is opening downward. So if you forgot that, get that in there, bless you. But otherwise, just remember, it's x minus h, so it was the -3, and then keep my sign on that one. Otherwise, that's all the information we're basically looking for once we can see a graph on these. Now, I'm going to start showing a couple of tricks here as we go along, because I like to shorten things up. So when we try to find the vertex, there's this recipe we use, this x equals -b over 2a. To find my vertex's x value, and along with it the axis of symmetry, because we talked about how those two things relate up here. Now, we'll do it fully out this way for right now, but I also want to show you a way to do it on the calculator, because we're always trying to find a way to save some time. So let's see here. What would my a value be here in number 9? They're like, maybe a little refresher. Is in order. Okay, so there's my standard form of a parabola, my ax squared plus bx plus c. So I heard some of you start to say it. My a value is going to be 2. What's my b value though? Good catch. There is no x term. It's just x squared and then down to my constant. So my b value is going to be 0 this time. So when I plug it into the recipe, the -b over 2a, I end up with 0 over 2 times 2, which is just going to be 0. Now again, that value will tell me my axis of symmetry is going to be x equals 0. That's good. But I don't know my vertex quite yet. I still need to know what the y value is. So to do that, we're just going to plug in the 0 where the x goes. And we love 0 because anything multiplied by 0 wipes everything out and turns it into 0. So my vertex is at 0, -3. Now, on these, I'm going to show you, like I said, I like to show you options on things whenever I can. There is a way to use the calculator to find your vertex. Now, in this case, it worked really fast. It went quick for me, so I'm not too worried about it. But let's say sometime it's something fractional or some other type thing, and I'm like, yeah, I wish there was an easier way to do this. Well, there is. If I take my equation, whatever it happens to be, and type it into my calculator and graph it, you're like, okay, so what? Well, there is actually part of my calculator a way to find out what a min or a max is, and here's how it works. If once I get it set, I hit second and then I hit trace, which is going to get me the calculate function here. Notice one of my options is going to be a min or a max. Now, if I don't remember what the graph looked like, but I still should know that this is going to open up because my a value is positive, which means I'm going to have a minimum. So I'm going to go down to minimum, and I'm going to hit enter. And my little cursor, my little blinky guy is going to show up. And here's how he works. He's going to trap the minimum in here for me and tell me what the answer is. So when it says left bound, as long as my cursor is somewhere on the left side of my vertex, and I know it's down here somewhere, anywhere to the left, doesn't matter if it's up here, down here, don't care. Once you get into the blinky guy there, hit enter somewhere over there, because then the question changes. It says, well, right bound, which means, hey, put the blinky guy somewhere to the right of where the vertex is. So again, that's anywhere over in this area. Once it's anywhere over here, hit enter again. Guess. Okay, we can guess. We'll try and get close down here. When we think we're pretty close, we're going to hit enter one last time. So there's 3 enters in this. And some of you are like, wait a minute, what's that -2.05 e -6? That would be the equivalent of having the decimal form, except it's so close to 0, we call it 0. So if you get something like what they're showing here, basically what they're doing is they are doing a scientific notation type thing. They're telling me the points at this -3. Well, that's so close to 0 with rounding, we would just call that 0. So whenever you see the E show up, basically that value is 0. So my vertex, my minimum would be at 0, -3. You're like, now sometimes that could be, you know, maybe more work than I'd care to make it. Now, if it's something nasty, maybe, we'll see. But as I'm working on any of these, and some of you may want to play with the calculator on these next two and see if you're faster than I am doing it mathematically. We'll see. But I know some of you just like doing these in your head too. So here my vertex, my x value is -b over 2 times a, so 2 times 3 is 6. There's my x is -1, which is going to be my axis of symmetry. And then my y, let's see here. -1 squared, bless you, is 1 times 3 would be 3. 6 times -1 is -6 minus 9. -3 minus 9 is -12. So my vertex is at -1, -12. So if any of you are calculator playing, now some of you may have noticed that's the one thing I didn't mention. One thing I'm playing with the calculator on these that some of you may not have a lot of experience with, since most of the stuff we do all fits in the screen right away. If sometime, there's different ways to do this, when I go to graph this, you're like, well, wait a minute, I can't even see the vertex. I mean, it's down here somewhere. So one of your options would be to change your window setting. Now it looks like my y values are getting further down. So maybe instead of my y value being -10, maybe I try -20. Hey, there it is. Because once I get that, then I could do second calc. It's a minimum again. And again, just make sure when it says left bound, your little cursor guy is somewhere to the left. And then when it says right bound, he's somewhere to the right. -1, -12, okay? So those are both options for you. It's good to know the recipe in case you don't have a calculator available, but it's nice to have the calculator available if it gets to be something nasty. All right, last one, I'm gonna go mathematically here. -1 for A and B is 4. All right. -b over 2 times -1 is -2. So negative divided by negative is a +2 for my x, which tells me my axis. Then my y, be careful, even if you're doing it manually. Okay, that negative is going to be not part of what I'm squaring. That's out front. And then 2 times 4 is 8 plus 5. So I'm going to have -4 since that negative is lurking. So -4 plus 8 is 4 plus 5 is 9. 9 is my vertex, well, no matter which format I'm doing it in. Now, when we get down to this next section, instead of doing every single one of these, I want to do 12 and I want to do 14 because there's one special thing about each one that we haven't really seen yet, and I want to be sure that we're aware of. Number 12. What's my A value for number 12? -1. Because you're like, well, wait a minute. A always seems to be first. This is written backwards, though. My A value is always my number that's in front of x squared. My B value is always my coefficient of x. And if I need C for something, it's always the constant term. So don't get fooled. So without even doing any graphing, is this one going to be opening up or down? Down. My a value is negative. So when we have one that opens down, do I have a min or a max? A max, because my point's at the top. Now, it says find the vertex. Check your answer by graphing. Well, shoot. If I'm going to do that, I might as well just graph it if I'm going to do that. So let's jump in here. We're going to double check with graphing, and then we're going to hit one where you really see the good use of this. And I can even type it in the way it is already. I don't have to put it back into standard form to make this work out for me. I can do exactly what it says and graph it. Okay, it's opening down. I feel good about this. Again, if yours isn't fitting in your graph, change up your window a little bit to kind of play. We'll get some fancy stuff with that too here. But if you can see it, again, it's second trace. But now remember, we're not looking for a minimum this time. We're looking for a max. So make sure you go to maximum in your calculate. And again, anywhere to the left of my vertex is fine, so that's A-OK. So we'll enter. Anywhere to the right of my vertex is fine. Enter. And I'll just head back towards the top here. And again, you can round when it comes to this. You don't have to tell me that the vertex is at 1.9999989. No. My vertex is at 2.9. And again, whether I do that with the recipe or I do it with the calculator, I'll get the same thing. And I'm perfectly happy with you doing it either way. Now, the one other thing I'll mention, because it says here, use the table feature to examine points and things. Because remember, if it comes out nice, like 2.9, if you have your vertex and you look at it in the chart and your vertex is in the middle, like I have it here, you'll see the symmetry. You'll see the 8s coming out from that, and then the 5s, and then the 0s. You'll see that that's the central point, and everything builds from it. So there's lots of little checks and balances you can do here to make sure that everything's working out okay. But then there's always the ugly one, like 14. Ugh. You're like, why does this look so nasty? Because you're like, okay, let's see. My a value is -2. My b value is -2. The a value being negative tells me it's down, which means it's a max. What if I tried to crank this out with the recipe? Because maybe I don't have a graphing calculator available. So I'm like, okay, -2 is +2 over 2 times a. Oh, it's a fraction. Oh, lovely. So now I'm going to have to stick this -1/2 in for that x and that x, and this is going to be a mess. Yuck. Well, what can I do? Oh, that's why we like having the calculator available. Because now I know where my x value of my vertex is going to be. And I could plug this into the calculator and get my values, and I'll do that in a second here. But here's why having the calculator and a little knowledge of it is so helpful. Because now, when I go ahead, and I'm going to go ahead and look at the graph of this first. Oh, it's not fitting. Let's get the window back. Oh, I'm still being bad. Let's see. My y max is going to have to be bigger. Let's play with this a little. That's better. So I see my max up there, and I'm like, okay, so I'm going to do second calc. So a second trace gets me the calc. And again, I want a maximum. So let's see, let's get to the left here. Anywhere to the left is fine. Then I'll right arrow somewhere to the right. Anywhere is good, doesn't matter. And my guess, I'll just try to be in the ballpark here. So you'll notice my x value is -0.5, -1/2. My y value is 12.5. Now, could I have done that manually? Sure. I could have done what I'm showing down here on the bottom. Now, I don't know how much I'd love to do that in my head, so I would imagine probably. But this is something that you can do with any calculator. You don't have to have a fancy schmancy graphing calculator to be able to do your problems with this. And again, some of you might even be smarter than I am and be using 0.5 instead of keep typing 1/2 in over and over and over again. But I get the 12.5 still. So I just want you to have options. But as long as you know your basics to figure out up and down, max or min without a calculator, when it comes to the other part, I don't care which way that you do it. And again, I like to try and keep everything as simple as I can. So if we bump this up a little, let's see, what do we got here? State whether each function is a quadratic. Basically, is x squared the largest degree? Is 2 the largest exponent that you're going to have on a single term? I don't know about needing to use a graph to check your answers, because if we understand the definition of a quadratic, which is something that's x squared, then we know. So for instance, 15 is no, because my exponent would be 1, which makes this a line, or makes it linear, okay? There's no curve to this. There's no u. If I were to graph it, it's just a straight line. But when I get to 16, that's what I'm looking for. There's my squared. So yes, that would get me a quadratic. But then I still have to be careful, because there's kind of some sharks in the water here. I see a squared there, but here's the kicker. If I FOIL this out, so x squared times x is x to the third minus 3x squared plus x minus 3. When you're looking for the degree of a function, you're always looking at the largest one. So in this case, my largest one isn't squared, it's cubic actually. So that's not going to work out for us. That's going to be something much different graphically. And then the last one that can get us is 18. Now this one's even trickier, because you're like, well, there's no other variables here. It's x squared. You know, what's the deal? Well, with this x squared being in the denominator, it's not really x squared. You're like, wait a minute, what do you mean it's not x squared? How can you say it says right there it's x squared? Well, let's look at this. 4 divided by x squared. Whoa. Okay, that doesn't look anything like what we've been doing. That's kind of funky looking. So here's why that is. We're really not supposed to have exponents in the denominator when we're working with something like this. So if I were to flip this back up, you're like, but wait a minute. Before, when we flipped, it changed. That was when we did negative exponents. So if I flip it up, it's going to make it negative. Right. Because that's why this graph is showing up the way it is. These are what graphs look like when you get into negative exponents. So here my exponent is actually negative 2, not positive 2. So that's another no. If it's x squared and it's in the numerator, okay, it's in the regular part of my fraction or non-fraction, then it's okay. But if it's down below, still doesn't work. Doesn't work, doesn't work, doesn't work, doesn't work. All right. I guess we just sort of talked about the next question. I got a little ahead of myself. Describe how you determine whether a function is quadratic. Largest degree is going to be 2. Okay, so if it's a quadratic, my largest degree, my largest exponent is 2. So it doesn't mean if it's less than 2 it works, because we found out that doesn't work either. It's linear, but it can't be more. It's got to be that 2. And then if it's a max or a min, let's see. If my a value is positive, it opens up and has, if value's positive, it opens up, oh geez, Harty, ha. If it opens up, it has a minimum, Harty, minimum. But if my A value is negative, it opens down and has a max. So every piece of these equations, these functions that we're working with, has an integral part of, does it open down, does it open up? Where's the vertex? Where's the axis? All of those things come into play with this. So finally, after having all these different ways to find all this information out, they're like, holy cow, it just never ends. Now, the review I am not going to worry about because I have pounded this and pounded this and pounded this. That's kind of getting to a point of being overkill at this point. So let's come down to vertex form. When we come down here, we see it doesn't always have to come in standard form, and you're going to be thankful for this in a minute because this actually makes life a whole lot easier. If it's in vertex form, and we've seen this form in other things, I don't have to use the recipe to find my vertex. I don't have to use a min and max in the calculator. I'm just going to go in and say, oh, it's the opposite of h and k. The opposite of h and k. There's my vertex. Negative 1, 3. Sweet. My axis is just the x value of my vertex. So my axis of symmetry is at negative 1. Again, that's the place where I could fold my graph in half and I'd have equality on both sides. So you're like, okay, but how do I actually, graph this now, if you want me to graph it? Well, I could plug in points if I wanted to, or I could let the calculator give me a couple of charted things. So again, it's your call. If you wanted to go to the calculator, and I'm going to get smart this time and use not 0.8. No. Negative 0.5. And then again, I can just type what I see here. And having that ability to kind of simplify some things, all right, that looks normal. So let's take a look at our chart. So I know where my vertex is. My vertex is at negative 1. So I'm going to get negative 1 in the middle. And I'm just going to take some of those other values. And normally I'll do 1 or 2 points on each side. It doesn't have to be overkill here. So like if I did negative 2 would be 2.5. And negative 3 would be at 1. And then I'll go the other direction too. So 0 is 2.5. And 1 is 1. And get my nice curve going there. And like I said, some of the problems simplify themselves to a point where it's not too hard to try and get these set up this way. So for instance here, so I just switch that sign.
Do you just have homework check and I'll give it to you because I wasn't here a second round?
Yep, it's right there.
And do we do anything else?
Nope.
Okay.
So what we're going to do is we get our 2, negative 4 working. My axis would be at x equals 2. And maybe you decide, you know what, I don't think this is going to be so hard. I'll just do it this way. I put my vertex in the middle of my little chart. I want a couple of numbers that are less than 2 and a couple that are greater, with the understanding I don't have to plug all of these in to get the answers. Because these two are equally far away from 2, I'm going to get the same y value out. So are these two. So I'm just going to pick the one I want to work with. So for instance, let's say I work with 3 here. 3 minus 2 is 1. 1 squared is 1. 1 minus 4 is negative 3. And that'll be the y value for both of those. So just pick the one you'd rather work with. In this case, I don't like the negatives. I'm going to do 4. 4 minus 2 is 2. 2 squared is 4. 4 minus 4 is 0. And again, if you want to plug it in the calculator, you can, because you're going to get the exact same things. So I'll plot the points that I have in my mini chart here. Make my graph. Keep life simple. So again, I'm not going to go into complete overkill with you guys on this, because again, it's just going to keep working that same way. So vertex form is probably, to me, the easiest of the 3 forms to work with, because I can steal my vertex straight from there, get my axis, and then just pop some numbers in. Now, intercept form is a real close second, though. It's going to set up this way, where you might have an a value, you may not. If you don't, again, we assume it's 1, it's going up. And you're going to find some x-intercepts, and then we're going to find the vertex second. It's kind of weird. So to find my x-intercepts, again, since I just set these equal to 0, I'm just going to take the opposites. So my x-intercepts are going to be at -3, 0, because again, they're points, and then change my sign on the other one. So -3 and +5. So you're like, okay, but how's the vertex work now? Do I have to like FOIL this out or something? Nope. To find the vertex, we find the spot that's halfway in between. Now sometimes I can do something as simple as just coming in one by one until I find that spot. So in this case, that spot would be 1. Or you could just do it like a midpoint. You could do -3 plus 5 and divide it by 2. Okay, it works the same way. And once I know what that is, I can just plug that in to get my y. So I'd have 4 and -4 would be -16. Ooh, that's not going to fit real well here. So my vertex so let's see here. So we got 1 and 1 there, so that's going to be negative. Holy cow. 1 and way down off the chart. Okay. That's okay. And then again, my axis of symmetry, though, still will go along with my vertex's x value. And again, that's all we're doing on these. And again, if it doesn't come out real nice sometime for the vertex, just add them up and kind of go that route. Want to get myself situated here. Okay. One last thing. They're like, ooh, he's going to flip on us. All right. Yes, the ones we always want to skip. They're like, oh, criminy. The story problems. All right. We will not be discussing a woodland jumping mouse. Why that showed up there, I have no idea. Because we're talking coffee here, people. All right. Souvenir shop. Reality here. Sells 200 coffee mugs a month for $6 each. The shop owner estimates that for each 50 cents they go up in price, he's going to sell about 10 fewer coffee mugs per month. How much should the owner charge for each mug to maximize sales? So what we basically see here is, ooh, we're going to do something that would end up like a parabola would normally. So here's how this works. We're going to kind of build it in words and then build it into the expression. But once you do it once this way, it'll work out real well. Normally, if you know something, you take its price times the quantity, and that figures out how much you're going to sell. We're going to do the same thing here, but it gets a little more interesting. Because now, okay, so we'll just call this T of X for total. Okay, my price currently is $6. But I'm going to start charging 50 cents more per each mug that I sell. So that's why my X is going in there. If I sell 10 mugs, okay, it'd be times 10. 100 times 100. My quantity, normally I sell 200. But I think I'm going to sell 10 fewer for every price increase there is. For every 50 cents my price goes up, I'm going to lose 10 coffee mugs in sales. So price plus increase times your quantity minus the number fewer you're going to sell. And I have to FOIL this out. Ooh. So I'm going to help out here. Give you the Cliff Notes version of foiling this out. It's like being able to fast forward. So once I FOIL this out, this would be my expression, or my parabola that I'd graph to understand where I could make my maximum in my sales. So here's how that applies to us. If I want to find the max, I need to find the vertex. Since this opens down, I'm going to have a maximum. So I say, okay, my b value, so again it's my negative b over 2a, will get me my x. So negative 40 over 2 times negative 5. All right, let's see here. Negative 40, negative 10 is 4. Now, that doesn't mean it's going to go up like 4 cents or $4 or something. This is for increases in price. So if I go back to the problem, I notice it's 50 cents per increase in price. So 50 cents per increase times 4 means I would make a $2 increase total in my price. So if I used to charge $6 and I'm going to add $2, I should be charging $8 per mug to make the maximum amount of money. And then, of course, to figure out how much that actually is, I would plug that 4, my increase value, into the expression. And that value is going to be my maximum fundage, which again I will help with the Cliff Notes version. My maximum monthly profit from selling mugs would be $1,280. So I just want to make sure we get the setup of this okay. So I want to just set up 25, and then I actually want to simplify the homework assignment a little bit. So here, same idea. We're going to set it up the same way. So we've got $20 to participate. We're going to increase it by $1. So we're going to have $20 plus 1x. Because again, it's the increase that's variable here. Then we had 70 people attending, but we think for each increase we're going to lose 1 customer. So it'd be minus 1x. And again, I would FOIL that out. And that's the expression I would use to find my vertex, to find my x and y values, to figure out what that maximum is going to be. Okay, now, to keep life simple on the homework, because I like simple. When you're working on all of the problems towards the beginning, I'm just going to make a note here at the top of this. I want to see how far this goes. Through 24. Yes. Okay. This entire part here, this 2 through 24 basically, that you're looking at all of these, we're going to make life simple. We're going to do a graph. We're going to do the vertex. And we're going to do the axis of symmetry. That's it. It's going to be asking you for the y-intercept and what's the x value of the vertex. Graph it, Figure out where the vertex is. Tell me where the axis of symmetry is. Happy. Whether you want to do it with a chart, whether you want to do it with the calculator, I'm fine with that. And the nicer thing about it is, well, I'll tell you the nice part, and then I'll tell you the not so nice part, but you'll think it's a nice part because you're getting something good out of this. Tomorrow you're going to end up with a work day.